All right. We are live. Hello, everybody, and welcome to the stream. I hope everybody is doing well tonight. Tonight, the plan is to start executing the plan that we came up with last night, actually. I know that's a little bit weird sentence, but there we are. So, what we are going to do is we are going to take a look at our asset system, and we are going to adjust the interface to work as we discussed last night. So we'll kind of review that tonight before we jump into the code, and then we'll start figuring out what the interface is going to look like, and we will from there actually begin the implementation. Before we do that, though, I do want to just take a quick second and thank the supporters of the channel, beginning with our elite partner, Javier Alazaran, who is the highest tier of subscription over on YouTube memberships/Patreon, followed by our partners, who are the next tier of subscription over there, Gerbolis Inc. and Matt Osgard, followed finally by everybody listed here in the supporters section. They are a combination of the other tiers of support over on YouTube memberships, Patreon, as well as Twitch subscriptions. So thank you all very much for your support. It is greatly appreciated and goes towards the cost of developing the game, running this channel, hosting fees, licensing, asset fees, stuff like that. All of that is super helpful. And of course, this channel would not be anything without you guys, the viewers, whether you're joining me here live on the YouTube side, the Twitch side, or if you're catching the VOD after the fact. Obviously, none of this project or this channel or any of this stuff would exist without you guys. So thank you guys for being here. I appreciate each and every one of you. All right. So with all of that said, we talked a little bit last night. We kind of came up with a game plan of some things that we want to do before we kind of proceed with the development of the game. These are all things that are going to make our lives a lot easier when we actually go to write further game code. And so the first thing we needed to do was close off version 0.9. So that has actually been done. We did that last night. And so now we're going to enter into a few small refactoring stages. The first of which is going to be a rework of the asset resource system. I guess I can't completely say it's a minor rework. It's kind of a medium rework, we'll call it at this point. So the way that we have decided that this is going to work, actually we'll review that in a second. I just want to kind of touch over the high level stuff, and then we'll kind of drill down into details. So the first thing is a rework of the asset resource systems. Then that will close out version 10 or 0.10. 0.11 will have either the scene refactor or the render graph removal, one or the other. And then version 0.12 will have the other one that we didn't do in 0.11. And then 0.13 will see us remove some of the legacy systems that aren't really all that useful. So a couple of them are like the lighting system, the camera system. We don't really need systems for those to manage those things. They can be managed otherwise. So we'll go ahead and remove those. That should be rather quick, and we'll probably incorporate a few new features, small features in with that. Maybe some bloom lighting or something, some bloom post effects or something like that. And then in 0.14, we're going to add animated messers. Once we get past this, we should be in a pretty decent place to actually get started writing some game code. We are going to need to do some work on the UI system as well. However, I don't know that we're going to use the standard UI for that, because the UI requirements of this game are pretty specific. And so we might wind up just writing out a bespoke sort of UI for this, and calling it that. So this is kind of the game plan to get us back to where we need to get in order to continue with the development of the game. So we did say we're going to be bouncing back and forth between engine dev and game dev, and we've done some game dev stuff, and now it's time to kind of go back to the engine for a bit. And the further we proceed down this path, of the overall development of the entire project, the less we'll have to kind of circle back to the engine and do stuff. But right now it's still kind of early on, so we're probably going to have to do this a few times. All right, with that said, Thank you for the follow. Appreciate that. Tomer Stock, good to see you as well. All right, so in 0.10, what we had discussed, let me make sure this is not behind my big head here. There we go. So what we had discussed was the removal of the resource system in general. So we're going to offload the resource handler logic to bespoke systems per resource type. This is already kind of done for us in some places. So this, I don't think, is going to be a huge deal. So things like the texture system, for example, already kind of do this for us. So the asset system will be the only one left, with the API looking kind of like below. We'll get to that in a second. And then in terms of auto imports, we're probably going to do away with those, at least temporarily. And then hot reloading, we may or may not wind up doing away with those, at least temporarily. We're not going to really need those right away, but us sort of refactoring and trimming down the way that our assets and resources are handled is going to save us a lot more time, at least in the beginning. So, for reference here, essentially we are going to have a sequence of, or a set of functions per asset type. And those functions per asset type will know about the underlying types that we're going to use. So for a binary asset, that's the example we're using here. We'll have a request binary sync, right? So this one's asynchronous, this one's synchronous, and then we'll have a package version of those two calls where you can request them from a specific package as well. So these two will automatically default to the current games package, whereas these two can refer to some other package, perhaps one that's imported or something like that. And then, of course, we're going to also have a release for that particular type of asset as well. And so the goal of all of this is to sort of get away from having to fill out this asset request info structure, and just kind of keep our interface, sort of lean and mean. And so that is kind of the goal. We're going to get started doing that tonight. So the other thing that we want to go ahead and talk about is our K asset type. So this right now is sort of used to determine what type of asset we're talking about when it comes to the actual asset that we're dealing with. So if I take a look at the K asset structure, let's see, I think that's going to be under, it's forward declared there. Where's the actual, here it is. So we have all kinds of different sort of high level stuff in here for assets, right? And not every single asset is going to need to know this, right? So we don't really need this sort of base structure, right? We can kind of get rid of this inheritance tree, if you will, for our assets. And we could just have only the information we need per asset. So another benefit to this is we're going to get rid of this stuff because not every asset, for example, needs an identifier or needs a name and package name or what have you, right? And so that's kind of the goal there. And so we should be able to simplify our code base quite a bit by kind of falling back on these things a little bit. Spiro, good to see you. How's it going, buddy? I'm late. I've failed you. You haven't failed me, Spiro. Not in the slightest, man. Let's see, over in the YouTube side, Michael asks, I'm a software developer, but I've always wanted to get into making a game engine, do mostly web-based stuff. Where do you recommend I begin? So, that's a bit of a loaded question, but I will answer that two ways. It depends on what experience you have with, what technology stacks, right? I do actually have a admittedly somewhat aged tutorial series now on how to make a game engine, or at least how to start making a game engine using TypeScript, right? And I made that back in like 2018 or something like that. It's on my YouTube channel. So there's that you could use that teaches some of the concepts behind it, but again, like I said, that's very dated, so that may or may not be useful to you. But if you're wanting to get into game engine development, generally speaking, you're probably going to want to learn a systems language if you don't already know one, like C or C++. Industry standard is C++. Usually I say, though, if you're going to learn C++, I say learn C first and then extend to C++. Either way, you want to have a decent command of that language first before you actually start writing a game engine. You do know a good bit of C. All right, perfect. Okay, so you're actually ahead of the game a little bit. So normally I say, you want to start off having a decent command of the language because you don't want to be learning game programming and the language at the same time. So if you know a bit of C, then you're already in much better shape than a lot of folks, right? And so what I would say is start looking into OpenGL, right? You could do what we're doing here and look into Vulkan, right? But that's not necessarily where I would recommend beginning. Vulkan's very verbose, allows you to shoot yourself in the foot very easily. OpenGL arguably has that same issue in other ways, but it's a lot easier to kind of get up and running with. So I would say start looking into OpenGL. Check out like learnopengl.com. Start following some of those tutorials and keeping some of those things in mind as you're sort of working your way through a renderer. And then when you're actually wanting to extend past the point of just making a renderer, that's when you're going to want to switch to, thinking about game engine architecture and things like that. But I would pick one thing at a time. Don't try and learn it all at once. Pick one thing at a time, focus on that, get decent with it, and then expand it. Whoa, we have a raid. Kuju, thank you so much for the raid. I appreciate that. Thank you so much for the raid. Let me do a shout out. So if you guys don't know who Kuju is, it looks like somebody beat me to it. I'm guessing Spiro. If you guys don't know who Kuju is, definitely immediately go give him a follow. First off, he is making a game from scratch using Jai as the programming language, and he's using OpenGL as his renderer. But he's written the whole thing from scratch. It's called Fat Goblins. It's a fantastic looking game. I'm really liking the direction that game is going. It looks great. It looks like it plays great, and it's really coming along to be quite the polished product. And so he's got it up on Steam to be able to be wish listed against. So definitely go check that out. But yeah, thank you so much for the raid. Welcome, raiders. Gonna dip and grab dinner soon, but what's scheduled for today? So today, we are basically talking about simplifying our asset system API, right? And we're actually gonna make things a little bit less generic, believe it or not. So we were talking about how we can make the interface a little bit easier to use. And so we're going to kind of rework the way that it works in terms of how you actually make the calls to actually retrieve assets and how they work in terms of requesting them synchronously or asynchronously, and then from a specific package or the game package. And so we've got this kind of interface here that we're going to use for that. So that is what's on the roster tonight. We're actually, we kind of came up with a game plan last night. And tonight we're actually going to start the implementation of that. I'm hoping Jai comes out publicly, because I would like to mess with it at some point, but I don't see myself converting my entire code base to it, but I'd really like to take a look at it. Because it does sound super interesting for sure. But yeah, thank you. Go grab some dinner and whatnot, Kujo. I appreciate the raid. So, Raiders, just to kind of give you guys an idea of what the heck we're doing here. So we've been building a game engine from scratch. It's called the Kohi game engine. We've been building it using C and Vulkan as our initial rendering backend. And I say initial rendering backend because it's cross-platform. So it runs on Windows, Linux, and Mac, which means that we are eventually going to support Direct3D as well as Metal as rendering backends as well. So the engine's been architected in such a way where the rendering backend, as I call it, or the API specific logic has actually been abstracted away to a plugin. And so right now all we have is the Vulkan plugin, but eventually we'll have a Metal plugin, and we'll also have a Direct 3D plugin. I don't know whether or not I'm going to do OpenGL, simply because we already kind of have everything else covered by the others, but that's kind of the plan. And so the entire thing was or has been developed pretty much almost entirely on video at this point. It kind of started as a tutorial series, and then it sort of morphed from there to a couple of different formats until we landed on live streaming. Game engines are far too complicated to kind of do a tutorial on past a certain point, right? So we've kind of had to migrate with that. But we do simulcast to YouTube and Twitch. And a little bit more about the engine itself. It is open source and free. So it is on GitHub. In fact, I will drop a link real quick there. So that link will take you to this page here. And on here, you'll be able to find links to, the YouTube and Twitch channel, Discord server. It's got about 1,000 people on it. And of course, GitHub. So if we take a look at the GitHub, it is all open source and free, right? So there will never be any sort of royalty fees or licensing fees of any kind ever for the engine. It'll always be open source and free, because this is designed to be an educational resource. And I believe that knowledge is power, and believing I believe that those things should be freely available. So the only thing is, it's Apache 2.0 license, which means that you can use it personally or commercially. It does not matter. There will not be any sort of licensing fees ever. The only thing that I ask is that if you use it, you say you used it. That's literally it. And then, we've got, just to kind of go over some of the things that we do have. I can't run it at the moment. But we do have a basic PBR pipeline running with cascading shadow maps. We have kind of a little testbed thing where we can, select objects and move them around in the world. We have the ability to render fonts, bitmap fonts, and what I call system fonts, which are true type fonts, including UTF-8 text. And all this stuff was written completely from scratch. So everything that is within the engine is within the engine's runtime is written from scratch. The only exception to that is some of the importers of a few asset types, because those weren't necessarily worth writing from scratch. But other than that, we've written this entire thing from scratch. So there's lots of information here. The only thing I would say is, it's still pretty early days in the engine. It's not something that I would necessarily use fully for production yet, only because it's very, very new. That being said, we are building a game with it currently. And so what we're doing is we've been building this engine for the past 4 years. And we're now at a point where we are sort of starting to kind of create a game with it, but we're going to have to bounce back and forth between the engine and the game a lot. Because we're going to find things that we had in the engine that we thought were going to work, and that didn't really work out, and that we're sort of having to change. That's one of the things that we're doing now. And of course, part of the idea behind this is that it's an educational series. So it's, we try things to see what works and what doesn't, and we do a deep dive on those things. Sometimes we intentionally do things the wrong way just to kind of explore why it's the wrong way, right? So, yeah, that's kind of the intro there. And so what we're doing right now is we've actually circled back to the engine. And we are updating the API for our asset system to make it a lot easier to use and a lot more straightforward. And we are also going to nuke our resource system and offload that to a series of systems that each handle their own respective resource. And so let me just catch up here on comments really quickly, and then I'll continue with that. Thank you for the follows, by the way. Appreciate that. Soulfoam. It's been renamed. It's not SOI anymore. It's now just Illumina. Arch, by the way, yes, we do use Arch. Let's see. Appreciate the you giving Kuju the shout out, Spiro. Appreciate that. Let's see. STL3's new GPU API is very nice abstraction as well. Yes, I've heard that, and I've kind of looked at it briefly, and it does look to be pretty sweet, to be honest. If I had to get something out the door really quickly, that's probably the route I would go, to be completely honest. Welcome, by the way, first time chatter. Let's see. LSR, good to see you. Let's see. I think soon TM for Jai. Yep, exactly. I expect Jai would get you into. Oh, John, I think you meant. I expect John would get you into the beta. If you email him, feel free to DM me or something if you want help. Okay. Yeah, the only reason I haven't yet, Kuju, is because, frankly, I just haven't had the time. And I don't know that I would have the time to like give it a fair, decent shot, right? But it is something I want to look into at some point for sure. Any inspiration from Casey? Yeah, so I do credit that, right? Right here. Like, this was initially inspired by that series, right? So there's definitely some inspiration there. But yeah, I kind of took a lot of his advice and kind of went my own direction with it, because there's a lot that I agree with, and there's some things I disagree with. Of course, that's the way it always works, right? But yeah, I do recommend his series to a lot of people all the time. Let's see. Okay. So I think I'm going to have to, let's see. As in data-oriented design. Yeah. So we, wait a minute. I think that was in, I haven't dove too deep into it yet, but I was seeing data-oriented, which I love. Yeah. So, one of the things that I'm actually switching to in a lot of our systems is more of a data-oriented approach. When we actually get ready to do our scene refactor, we're going to do that in a very data-oriented way. Let's see. Why do they need to code directly to Direct3D and Metal when using Vulkan? So Vulkan is only Vulkan is not supported on macOS natively. So we have Vulkan support via something called Molten VK, which essentially translates all of our Vulkan calls to Metal under the hood. So it's just a translation layer. And that's how we're actually getting Mac OS to use Vulkan, right? But eventually we are going to have to write our own Metal layer, which we are going to do on stream as well when I get ready to tackle that. So that one is definitely needed. In terms of Direct3D, it's not something I have to do short term, so I'm probably not going to do it short term. But the reason I want to do it is because I eventually want to expand support for this to consoles. And so if I wanted to support the Xbox, that would need to be Direct3D, because that doesn't run Vulkan. So, that way it also gives people an option. If they're on Windows, they can use Vulkan or they can use Direct3D. So I hope that helps. All right. By the way, STL3's GPU's API is most close to Metal, per author's words. That is what I've seen. It's also extremely close to Web GPU, which is also pretty Metal-like as well. So I feel like once I go ahead and tackle the Metal layer, I'll probably also be able to reasonably probably tackle like the Web GPU layer, maybe at some point in the future. Metal is a good middle ground. Yeah, so I full disclosure, I've not programmed anything in Metal, so that's going to be an interesting experience because I'm going to be learning that on the fly as we program it on stream. But yeah, from what it looks like, it's a pretty solid API for sure. I think the best out of all of them was like old school DirectX. In terms of APIs, they always had the nicest API, at least back in the day. I can't speak for DirectX 12 because I haven't used it yet. But yeah, Vulkan has its issues. We'll put it that way. Molten VK is not good. No, Molten VK is awesome, right? But at the end of the day, it is a translation layer, right? So you do incur that overhead of having all of that translation having to happen from your Vulkan commands down to Metal. And there are obviously bugs and issues with that. So it's not that it's not good. It's awesome and it's great. It's a great bit of tech, clever bit of tech that we're able to leverage. But, I don't want to rely on that going forward. Thank you for the subs over on the YouTube side. Appreciate that. Okay. Do you have a preference to Vulkan versus DirectX? So yeah, I guess I just kind of answered that, but in terms of like DirectX DirectX 12, I would say DirectX, right? But I haven't used DirectX 12, so I can't answer that yet. But I'm thinking DirectX 12 is probably still going to be nicer than Vulkan in terms of API. I like Vulkan a lot, but it has its issues, right? And its API is one of those issues. But yeah. Thank you for the stretch redeem. Let's see. AMD's Mantle. Vulkan is based on... Wait, Vulkan is based on that. Wasn't that verbose? It was, but it wasn't that bad. Yeah, exactly. Yeah, that was... So AMD donated Mantle to... Kronos. And Kronos basically created Vulkan from that. You probably use Zinc Multima VK to get newest OpenGL stuff working on Mac. Yeah, or you could just write it in Metal, right? Because one of the things that I want to do is I want to have the least number of dependencies possible. That's one of the goals of this entire project. So Molten VK is a dependency, right? Obviously, Vulkan, DirectX, Metal, those are dependencies too. You can't really get around those ones, right? But any layers in between that I can eliminate, I'm going to eliminate them for sure. All right. We should probably actually raw dog in it, respect it. Yeah, exactly. That's kind of more or less what we're doing. All right. So what we kind of have now is this kind of hierarchical structure. Where we have this sort of K asset that's sort of a generic asset, if you will. And then each one of our specialized assets sort of has this base structure that's in here, so you could just cast it to that and then get all these base properties. Long story short, we don't really need all of this stuff for all of our asset types, right? And so I kind of want to get away from... I want to get away from that, and I want to really just have the asset types stand on their own without them having to... in fact, yeah, some of these are even wrong. Like this one doesn't include a base, for example. Or I guess this is static mesh geometry. So yeah, there's some things that we have to figure out here in terms of how we want this actually, all this stuff to work. And so what I'm probably going to do is... in a lot of cases, I would probably write the new system alongside the old system and then rip out the old system. But I think we're just going to tear the Band-Aid off here and actually just start overwriting the old stuff altogether. So I think what we're going to do is we're going to create a new branch. And we're going to call this... assets. And so this is branched from the release 0.10, right? Because we might wind up having multiple branches that we're working on at the same time while we're kind of trying to figure some of this stuff out. So we have all of this kind of stuff like K-asset metadata, all of this kind of stuff that I don't really think we need, right? Asset importers, which are going to externalize. We have type defs for things like hot reloading function callbacks and all this kind of stuff. I want to simplify all of this stuff so that we can actually kind of have a system that's just easy to use. and easy to understand. So I think what we're going to do, I wonder if I should just completely nuke all of this and start over. As much as I don't want to do that, I think it might be like, although some of these structures are going to wind up looking the same, so maybe that's not the best way to do it. How about this? We have, so this is K asset types. Let's circle back to the types. And we'll go to, oh, you know what? We call that the asset system. We should probably, maybe we rename this to the K asset system, right? Because we deal with K assets. So right now, our asset system interface looks like this, right? We have something to deserialize our system config. We have an initialize for the system itself, a shutdown for the system itself. And then we have this request release. And then on handler result, which is, let's see, from an asset handler when an asset is fully loaded or ready to go. So I wonder if, because this essentially registers a callback, which we don't actually need. And we don't actually need this, and we don't actually need, like, all this asset type is binary. I don't think we need this stuff either. So I'm kind of like leaning towards like maybe we just eliminate this entire API and just rewrite it from scratch, right? Maybe we'll keep this bit, right? Because that's not really going to have to change. And let's get rid of asset request info, right? Because that's kind of ridiculous. We don't need that. We'll get rid of this hot reload callback. The asset system config, I don't know. I mean, we might wind up redoing that, but I'll keep that for now. So let's get rid of from here, request, release, handler results, binary, reload callback. Let's get rid of all of that, right? And we're actually just going to do, I'm actually just going to take a copy of these and paste them in here. And obviously we're going to have to do this for each individual asset type, and that's fine. So what I'm thinking here is, and why do we not have, oh, this is actually the calls to it. So we're going to need struct asset system states, right? This is going to actually be struct asset system states. We'll do the same thing here, and we'll do the same thing here. Why does it not like? Why does it not like? I guess maybe I have to fix the rest of this. Okay, so we're gonna do const character array name, and we'll also do a callback. So the asset loaded callback, we can go ahead and define up here. We only need that for asynchronous loads, right? So we'll do, didn't we actually have, we might have already had this in here. I might have actually nuked that. Let's keep this. Right, so we can say PFN asset system. We'll say asset. Let's do K asset binary loaded callback, right? And so this is going to be binary, right? So we have a listener that we can pass along with that, which I suppose does make sense that we can do that. So we can take this one, move this down here with these guys, and then do, let's see, we'll do this. Right, and we're probably also going to want to do like a void pointer listener as well. Okay. Now, why is this bleating so hardcore? Why are you complaining? Oh, because I have equal signs in here. That's why. There we go. Okay. So requesting a binary asset. This is going to be an asynchronous load. Load. Right. So the way that this guy is going to work is we request the asset, right? And we're immediately given a pointer to that asset. But that asset will not most likely be loaded when this function returns, right? So this just kicks off, this will essentially kick off a job internally that'll say, we need to load this particular asset from disk. We'll go ahead and allocate the memory for it, return a pointer for it, and then we'll take the name of the assets, a listener potentially, and a callback to be made once the asset's loaded. These two things can be optional. So the listener and callback, I think, will be optional because not every asset has to be like immediately available or needs notification as to when it is loaded. It could just kind of be used whenever it's loaded, right? And we can kind of check the state on that particular asset to see if it's loaded potentially. So we can, for the asynchronous load, provide a callback and listener or not. And then the synchronous request does not need a listener or a callback because it immediately returns. And it loads that particular asset from disk synchronously, meaning it blocks until that actually loads, right? Which is useful if you're already in the context of a job that's running on another thread. That might be a nice linear way to go ahead and handle it, right? And in some cases, it's not going to matter that you do this because it'll be a nice quick load, right? So in this case, all we'll need is the name of the asset, right? And so this will be async load from game package, right? And then this will be a synchronous load from the game package. And then we'll have from a specific package, we'll have the same thing, right? So we'll do package name, right? And an asset name, right? And then, of course, we'll also have this same callback here, right? And we'll have an optional listener, right? And of course, again, this is the asynchronous version from specific package. And then a synchronous load from a specific package, right? And so this one is actually going to have package name and name, right? And then, of course, to release it, that is just going to be probably return type of void. And then it'll be, all we need is just this. And the asset itself, right? So that's going to be k-asset binary asset, right? And so I think, we would essentially wind up doing this set of functions for each individual asset type. And I think it's nice and explicit. It's type safe. We don't have to worry about doing casts based on, some enumeration that's passed or any of that stuff. We always know the types that we're dealing with here, and I just think this is going to be a lot easier and simpler to use and extendable. I keep hearing that Kronos has future plans for while OpenGL is deprecated. I assume you're talking about Vulkan in that case. I think OpenGL should be adapted by the Zinc team so they can maintain it and add some cool new features like ray tracing and such. Yeah, so my theory on OpenGL, and this I think might already actually be starting to happen, is platforms that don't want to support the actual OpenGL calls anymore are just going to treat that as a translation layer and convert it to Vulkan anyways, or Metal, or whatever, what have you. I suspect that might already even be happening over on the Mac OS side, for example. They're probably going to do away with the actual, underlying driver logic that deals with OpenGL specific logic, and instead of doing that, they'll just funnel it into Vulkan or Metal or something. I think that's what's going to happen long term with OpenGL. So they can say it's deprecated, but they still support it. All they do is just pipe it somewhere else, and then they don't have to have the underlying support for both. I think long term that's what it's going to be. Oh, was your previous message where you decided to start learning Vulkan? Yeah. Yep. I always say start with OpenGL, but quickly jump to Vulkan once you're decent with OpenGL. All right. Thank you for the follow, by the way. I appreciate that. Okay. So this is kind of what I'm thinking our interface is going to look like. So we'll probably just wind up having one of these callbacks per asset type. The benefit of this being also that if we have to pass additional properties of some sort for different asset types, we can actually do that if we have their callbacks actually separately sort of defined as well. So when we start talking about requesting a binary resource, maybe we've got an additional property that needs to go with this that maybe a texture or a image resource wouldn't necessarily have to have, right? So if we take this over to Asset System C, and you'll note that we have a whole bunch of other stuff in here, right? All of which is going to wind up going away. Because there's like a lot of state passing and there's lots of inversion of control and other stuff happening in here, which I'm not really a huge fan of. We have these asset handlers, which I think probably also could wind up going away and maybe just be a part of this whole asset system. Like maybe we put all of our asset handling code in here. I haven't really decided that just yet. We'll see. But we have this asset system request, right? So this is all the, all the old stuff. To do remove old stuff. And so it's not none of this stuff is actually referenced anywhere externally anymore because we've removed the API, right? So more than likely, we could probably just quite frankly nuke all of this stuff, right? I think you know what? Yeah, let's do it. Let's get rid of it. Because sometimes, we just need to rip the Band-Aid off. We're going to write this stuff from new. So let's go ahead and get, so that's release. This is asset system request. Okay, we're going to remove all the old stuff. We're not even going to do it. We're just going to remove it, right? Oh, I forgot though, in asset system H, we do need to export these functions. So we should probably do that now before we forget. Oh, I don't need to export the type def. That's dumb. Okay. Oops. All right. We don't need this. Okay, so async load versus regular load, right? I think what we're going to do is we're going to handle synchronous first. Because ultimately the way that this is going to work is when we set this up, the asynchronous request is ultimately going to use the synchronous logic just in a jobified form. So we'll go ahead and define this one first. So the first thing that we're going to want to do, obviously, is some sanity checks. So, if we don't have states, or we don't have name, or, or string length name. We don't have, right? So that's, less than 1. Then we'll go ahead and just do k-error, function name requires valid pointers to state and name. And then we'll just do the function and then return 0, right? So our error case in all of this is going to be we return essentially null if our asset request fails for some reason, right? So we have that. Otherwise, we need to do a little bit of thinking about how we want to actually manage all of our different asset types, right? So one way that we could do this, and I think it makes sense, we could, excuse me, we could just, allocate this memory that we're going to return whenever we go ahead and perform a request, right? We just allocate the memory right then and there, and we just return it, right? Yes, that causes fragmentation. However, I don't see a scenario in this case, and if we're reasoning about the data that we're using here, I don't see a scenario where we're going to have to blast through a bunch of assets of a particular type in a tight iterative loop, right? I don't see that happening. So I don't feel like fragmentation or cache misses or something when it comes to dealing with assets is going to be a huge deal because it's not going to be something that is referenced in a tight loop, right? And so I think we at this point can go ahead and just say we can leave this up to the individual asset system itself as to how this is handled. But I think for most of our asset types, we probably can go ahead and just say, we'll just allocate the memory on the fly as needed. Let me see. Thank you for the follow, by the way. Vulkan Engine 265, are you able to render a triangle yet? Oh yeah, we render all kinds of stuff. Obviously this doesn't build because I'm ripping apart our asset system, but yes, we do have all kinds of stuff that renders. Yeah, for sure. Here's a couple of aged screenshots, right? But like, we definitely are way beyond that point. In fact, we are circling back and kind of fine-tuning some of our systems to make them a little bit easier to use. So yeah, we in fact, our Vulkan render is probably one of the most stable parts of the engine in general. We're not going to really have to refactor that at all, I don't think, for the game that we're working on. It's a lot of stuff that surrounds that we kind of need to eliminate some tech debt on. Thank you for the follows, by the way. Appreciate that. OpenGL is nearest to perfect when it comes to write once, run everywhere scheme. Yeah, not necessarily. You've never had to write it for mobile devices. Although I see that you quoted that, so I don't know if that's like an air quote, like sarcasm thing. Graphics APIs are in a bad state at the moment. No one is perfect. Yeah, I would agree with that for sure. Like, I know Jonathan Blow was saying something along the time, like he went on one of his rants about graphics APIs, and he was saying, you know, why can't it be like if you want to draw a rectangle in the screen that there's just not one function that you say, I want to draw a rectangle here of this size, and it just does it, right? There's no graphics API out there that does that, which is, I agree, should be a simple thing, right? Should be a long solved problem, and it's just not. Anyway, so what we're going to do is we're going to do the naive approach here for assets. We're going to do a k-asset binary, and we are going to say that this one, we'll just say out asset. It's k-allocate. We'll do size of. Actually, I have something that's even better for this. Let's do k-alloc type, right? That way we don't have to do size of all the time. K-asset binary mem tag asset, right? And when we go to release this thing, we'll essentially do the exact opposite, right? So if states and asset, then we can just do k-free type. And so the block will be assets, the type will be k-asset binary, and the memory tag will be asset, right? Obviously we need to add more to it than that, but that's essentially the way that is going to work. Okay, so at this point, for our binary asset, we probably ought to look at the structure itself and think about what all is in it. So we do have this sort of k-asset base, the size of it, a void pointer to the content. That's all well and good. Do we need this k-asset base? I kind of want to get away from using it. So I'm kind of leaning more towards like, maybe we don't need some of this stuff, like generation. Like, I don't know that we necessarily need that. The intent there was to use it for hot reloading, right? But like, if we hot reload it, we have a callback that's going to be made anyways. So do we really need the generation for that? I think not. Size, we can include that in the base structure as we have. So name and package name might be worth including, right? That way we'd actually know what we're releasing, I guess. I kind of think that we still don't need it though. Maybe for debug purposes, but I don't know. K-asset type, I want to actually eliminate entirely, right? I want to actually get rid of this enumeration. So we're going to look at getting rid of that. K-asset metadata, if we take a look at that, that has the asset version, again, do we really need that? We have the asset path and the source asset path. Now, these might actually wind up being useful. But I feel like they'll be useful in certain scenarios. And I don't feel like it's something that we necessarily need to hold on to, at least at the moment. I figure we can always add them back if we need to actually track it, right? And then we have tags and an array of tags, which, again, like, I don't feel like we need this stuff, right? So I think that's like metadata in general can go, right? And then file watch ID, again, if we are hot reloading an asset, we could probably store that in the system that's listening for the hot reload anyways. So we probably don't need to store it as part of the asset, right? So with all of that said, I think we can actually get rid of base, right? And we can just have size and content for our K-asset binary. You could argue that maybe we include the name there, but I don't think we need it. Maybe for debug purposes, right? But I really don't think we need it. Because why would we need to know the name of it after it's already loaded, right? The only time the name really applies is when we're actually requesting it from the asset manifest. So again, like, I think it's just extra stuff that we're tracking that we don't really need to be. So, with that said, the only thing that we actually have to do now is reach out to our packaging system and go from there, right? So one thing that we don't have though, these are, did we deleted callback? Yeah. Okay. So these actually can go away too. Let's get rid of those. Let's get rid of hot reload callback, hot reload listener. It's not allowed for user types. So I think in terms of different types of assets, right? I think all the stuff that we're going to have here is going to be sufficient for user types as well, right? Like, user types of assets are not really going to be required, I don't think, right? Because we'll have everything to load, like a binary asset where you need to load just a blob of bytes. We'll have something to load text. We'll have something to load KSIN. We'll have something to load images. We'll have something to load, all the basic types that you would expect. And then you could, load various resources based off of that. So I don't feel like this is relevant. And actually, asset handlers in general are something that we probably just don't even need to concern ourselves with. So that being said, if we look at the binary asset handler, which is this guy, all we have is like stuff we are already going to set up anyways within the asset system. So I think this is just another kind of layer of code that we can get rid of. I really don't see the need for this, right? I think we could probably do straight from the VFS, we could probably just load the assets that we need, right? So for this guy, I think we can do VFS, and then request. So we do have request asset sync, right? So maybe let's use that. So we'll do state VFS, and then VFS request info. This might be, I'm not going to refactor this now, but I think our VFS might actually need a little bit of attention too. So let's see, VFS request info. let's just put this, actually, let's just do this. Right, and then we'll do info here. And so this again is like, how do we have to fill out like a request info for this, right? So there's like this multiple layers of request stuff that I'm trying to get rid of. I think I'm okay with it at the VFS level, but I think beyond that, probably not, right? So asset name is just going to be kname create, and it's just going to be name. And then package name is going to be, we don't actually have a way to track that yet. So that's going to actually have to be state. State application package name. We'll have to put that in there. Context and context size. We don't have those things. We don't have a context for a synchronous asset request. Get source is going to be false. And that's going to be something that we probably are going to have to think about as well. Source, the whole source asset thing versus primary asset thing, I kind of am thinking about getting rid of that too, and just having like a flat import process that is external, right? So is binary is going to be true. Oops. And then let's see. We don't have any import params. We don't have any of that. Watch for hot reload is going to be false. And I think that's probably going to do it for right now. The only thing is, does this... All right, so let's close this off. Does this... This does give us a VFS asset data, right? So VFS asset data. Oops. Right, and then data, we can do, here's where we actually grab the data for the file, right? So we can say out asset size is equal to data size, right? Out asset content equals k allocates. Actually, let's do, let's do k allocate. Size of is going to be the out asset size, and then the memory tag is going to be asset, right? And then we'll do k copy memory. K copy memory. I thought it was, wasn't it? Isn't it? Yeah, K copy memory. I thought so. Okay. K copy memory. So the destination is going to be out assets content, and the source is going to be data. Oops. Data bytes, right? And then size is going to be out asset size, right? And then all we have to do is return out asset. Let's see, why is this? Oh, I bet that's because that's void. I guess it doesn't have to be. But kind of when we read it in, we need it to be non-const, right? Because once we load our asset, like, it should never be... I guess, okay, let's do it this way then. Let's do this, right? And then we'll do out asset content equals content. We'll do that. Okay. So, this is the way that the synchronous request is going to work. Um, I think it's pretty straightforward, right? And probably what we'll do is, at least in the short term, we'll probably just say the asynchronous request will just route to the synchronous request temporarily. And then when we go to Jobify it, we'll reroute it later to be properly Jobified and all that stuff on a different thread. So I think we can just do... actually, how do we want to do this? Right, because we could actually... Should I go ahead and just do this now, I wonder? Maybe I should. Maybe I should hook it up to the asynchronous request for the VFS. Let me catch up on chat here. STL GPU can't do geometry shaders yet. I mean, I guess that makes sense, right? But like, I haven't really had the need to use a geometry shader either. At least not recently. I mean, it's, you know, beyond debug things, generally speaking. You're only limited to vertex and fragment shaders on it. Meaning it doesn't have compute, or it does? I thought it did have compute support. Oh, you left it out because it was separate. Okay, I gotcha. Okay. Sakelos Music, how's it going? Good to see you. The joys of making marginal decisions about layering. Yeah, exactly. But I think this, like in general, this function call is a hell of a lot easier to use than having to do, you know, essentially this kind of crap all over the place, right? So if we like, this kind of thing makes sense at the VFS level, but like when it comes to requesting an asset, it should be as simple as possible. So I think I'm pretty happy with that. The only thing, we do need the application package name, right? So that's actually got to go. Let's see. The asset system state here. We are going to need. Kname application package name. Right, so this is the name of the default package to use, i.e. the game's package name. So that is something that we should probably pass in via the asset system config, I'm thinking. So this could also be kname application package name, right? And then when we do, actually, do we have here's the asset system here. So how do we want to do this? We probably don't need to explicitly get this out of here, right? We probably can just say oh lol, this is actually that had a old reference in there to it. Let's see. So don't we have... I want to say it was in here. Package name, Shadows of Illumina. Okay. So we could probably just get this out of code, right? But for now, I'm going to add it to the config. All right, so here we'll have application package name equals that. And then when we deserialize the config, we can get the application package name here, right? So we can say Els Dragoon raiding with a party of 33. How's it going, gents? Early raid tonight. You guys beat me to it. How's it going? How was your stream? If you guys aren't following Els Dragoon, definitely do it. They are a duo making a game on original NES hardware using 6502 assembly. Giga Chad stuff up in there. So definitely give those guys a follow. And the game is looking pretty freaking sweet, by the way. Every time I'm able to tune into their stream, it's just looking better and better. So yeah, definitely go give those guys a follow if you're interested in that. It's really cool stuff they got going on over there. You guys are on the East Coast right now? I thought you guys are West Coast guys usually. Your stream was a wild one-off. In the same... Oh, you guys are in the same room. You guys are never in the same room. That explains it. Okay. Okay, that explains the time difference. I thought you guys were both on... I thought you guys were both on the West Coast for some reason. Okay, that makes a lot more sense. Okay. Well, that's pretty cool. I'm sad I missed that one, actually. You just punish him and he stays up late. Yeah. And what you're saying is whenever I raid you guys, I'm further punishing Roland, is what you're saying. That's what I'm getting from that. Oh, that's really cool, though. I'm going to have to watch the VOD. All right, well, Roland, my apologies for that. All right, so... just for the raiders, for you guys who are not familiar with what we're doing here. So we've made a game engine from scratch using C and Vulkan. Vulkan is our initial rendering backend. So I say initial rendering backend because we're using that for now, but we're also going to support Metal and Direct 3D. It runs on Windows, Linux, and Mac OS desktop platforms with more planned in the future. So this was designed to be sort of an educational exercise, right? To show a way of building a game engine. It's not necessarily always the right way to build a game engine. It's just a way of doing it, right? And sometimes we specifically do things the wrong way to explore why that's the wrong way, right? We do a lot of experimentation. We do a lot of trying things out, seeing what works, what doesn't work. Sometimes we get really lucky. Sometimes not so much. And so with that, comes some refactoring and tech debt, and we're resolving some of that now. But the idea is that we wanted to make a game engine from scratch using C without any libraries to speak of. The only places that we're allowed to sort of cheat on that are various types of asset imports. So things like reading various image formats. I've used STB image for that. I've used something small to read a true type font library, that kind of stuff, right? But other than that, all of the core game engine, the runtime, all of that stuff is written from scratch. And so that is kind of what we're doing here. Yeah, definitely, Nick. If you have to run, go for it. I appreciate it. We'll talk soon, though. Thank you again for the raid. And so, actually, I should probably drop a link there, so you guys have that. So that link will bring you to this website, which is sort of the main hub for this whole project, right? So we do stream to YouTube and Twitch. We have a Discord that's over 1,000 people at this point. And the project is available on GitHub. So the engine itself is free and open source. So it is Apache 2.0 license, which means that if you want to use it commercially or personally, independently, does not matter. All that I ask is that you say that you used it. There will never be any sort of licensing or royalty fees of any kind ever. This is an educational resource, and I think that kind of stuff should be free. So we do have, in terms of some features, I really need to update this page, but we have a PBR pipeline, physically based rendering pipeline. It's a basic one for now. We're adding to it constantly. We have cascading shadow maps. We have our own custom UI system with text rendering, complete with bitmap fonts, which this is an example of a bitmap font. And then we have what I call system fonts, which is TrueType fonts, including UTF-8 fonts as well, generated on the fly. And so these are a couple of, albeit, dated screenshots, but these are from our testbed application that we use as sort of our test driver for the engine. So one of the things that we are doing right now, let me pull this up real quick, is we are actually in the process of developing our first game with this, which anytime you have something like a game engine that's brand new, you're obviously going to run into, issues with it, right? So there is lots of going back and forth between, the engine and the game code. And right now we're kind of doing some engine stuff, but we are building a 3D isometric action RPG called Shadows of Illumina, and it's based off the world of Illumina here that you see on this map. So we've actually done some mapping, we've done a little bit of lore creation, we've done some of the background of this. We're still building out the map. You can see there's sections here that aren't filled in and stuff like that. But we do actually have a decent plan coming together for the game, right? And we're doing all of this on stream. So I hope all of that makes sense. Specifically, what we're doing in the stream tonight is we are reworking our asset system / our resource system to make everything a little bit easier to use and a little bit more concise. So we had a couple of things that we did in the engine where things were a little bit overgeneralized to the point where it just made them kind of needlessly complex, right? And this is one of those things where I was saying, we have multiple ways of doing things. Sometimes we get it right, sometimes we don't. In this case, I believe that we made it a little bit too generic, too open-ended. And with all that generality comes a lot of complexity. So we are actually aiming to eliminate that. And so we had separate asset and resource systems, which was kind of cool. It worked decently enough, right? But it was still kind of complex to use at the end of the day when it comes to the actual user code or the application code. And so we're sort of tearing that down and rebuilding it, but rebuilding a lighter weight version of it that's not quite so complex. And so we actually we did a retrospective on last night's stream about all of the different pain points we've kind of run into so far with trying to make the game. And we kind of came up with some statistics, the good, the bad, that kind of thing. And came up with a game plan of things that we are going to fix. And so I guess as part of the intro, I could also, kind of hit these stats really quickly. So our first commit of the engine itself was back on February 28th of 2021. There have been 472 commits to the main branch at the moment. There's 77.5 thousand lines of code. And then we have this number keeps actually incrementing, right? But we have 265 full episodes on the game engine series, plus some minor ones in between, before we actually started even making the game itself. And so we kind of went over some of the good, some of the bad, but ultimately we landed on this gameplay, or this game plan here, right? So we did we did close off the last version of the engine, which was 0.9. We've moved on to 0.10, and now we are doing a rework of the assets and resources to improve the API usability. So that's kind of what we're in the middle of now. And then next, we are going to do a bit of a refactor on our scene, and we're going to be removing our render graph because we had a render graph set up. The render graph was pretty cool, but it wound up being, again, one of those things. It's like it's so general that it just adds a lot of complexity, and we want to kind of go back to keeping things as simple as possible. So. The next couple of versions are going to be dedicated just to kind of cleaning up some of those things and making them simpler and easier to use. And then after that, we're going to be removing some of the really unused legacy systems and incorporate a few small features. And then we're going to be moving on to animated meshes. That's the last big piece, aside from arguably physics, that we could add. Although... this particular game is not really going to require physics, so we don't really need to add that. And so, yeah, we kind of have, we kind of put up a to-do list of 0.10, which is what we're working on now. And so, yeah, we're in the middle of that. And we have redefined what our API is going to look like for all of our assets. And this is kind of where we are at in terms of that. So I hope all that makes sense. Anyway, give me 1 second. I have to blow my nose. Allergies are killing me today again. Let's see. All right, sorry about that. Okay, so we were actually in the process of adding a new property to our asset system configuration, which is for the application configuration, the application package name. So we have this concept of packages for our assets, and you can have multiple packages that come with like engine plugins and things like that you can load. And so our asset system is aware of those. You can either, initially it always required you to provide a package name that you were loading an asset from. But 95% of the time when you are building a game, the asset package you want to load from is actually just the game's asset package, right? And so we essentially have created an API point that doesn't require the package name, that just assumes that you want to load from the application package. And so we need a way to configure that. We already added this to our application config. We just need to kind of pipe that through as to what that actual name is. And so we'll have that here. And we're going to do case and object property value string as kname, which is what we're going to want. So we want the root, tree root, and the name of the property that we want to extract is going to be application package name. And the out value, or where we're going to store that, is going to wind up being the address of out config application package name, which is a kname, right? So if that does not exist, that is required. We are going to bleat about it and throw an error, right? So we're going to say application package name is a required field and was not provided. Now that we have that, we then, when we make a reference, or a request rather, to our virtual file system, we can just pass that along, right? So that is going to fix that problem, and then that is going to finalize the synchronous request for a binary asset. So the asynchronous request, which is basically the same function minus the sync, right, is going to work a little bit differently. So we probably are going to, I'm going to copy this as a reference, but like we're not going to be able to do all of it necessarily right away. So, in fact, I can actually close that buffer. Okay, so we still need to do a check against state name string length, right? However, let's see. I think we actually said that listener and callback are going to be optional, right? So we can load an asset asynchronously. We're going to immediately get a pointer to it, even though that asset might not actually be loaded yet, right? But we are going to get a pointer to it immediately, even if we request it asynchronously, so that we have an immediate reference to it, right? But what we can do is we can provide a callback to say, hey, when this thing is actually loaded, we want to execute this callback, right? And then we can also pass like a listener context that'll get passed on to the callback along with the asset binary, right? And so when we actually go to perform this request, we're obviously going to set up the memory just as we did before. We're going to fill out a request. However, when we do this request, we need to provide a couple other things as well. So what we're going to do is we need context, right? So our context, let's see, is going to be, oh, you know what? We might actually need, what is the, I need to actually create the VFS callback, which is this. So when we make an asynchronous request to the VFS is going to require a callback, right? So we're going to have this here. We're going to call it static void. And then I guess we'll do on binary asset loaded. Let's see, on binary asset, I guess let's do VFS on binary asset loaded callback. That'll work. Okay. So we'll want to provide this as the callback. Oops. So I want to do just that. Okay. And then in our VFS data, let's see, we have the results. We have some information about the asset itself. Context passed in from the original crest. I don't think we actually need the context size in this case. I think we could just ignore that. So, and then we also have size of the asset and text or bytes. Okay, so this is what's going to actually handle this bottom part for us up here, right? So for a asynchronous call, we're basically going to say, well, here's the VFS callback that the VFS needs to make once that job completes. And then from there, we do context is going to be, can we do, so we need the listener. We actually need a couple things in terms of the actual context that gets passed along. So when we pass this stuff to the VFS, we need a copy of the listener. We need a pointer to the listener. We need the callback function if it was provided, right? So both of these if they were provided. And then we need a pointer to the asset itself, because this doesn't actually have a pointer to the asset, I don't think. This actually just has the asset data itself, but not a pointer to an actual asset, right? Because the VFS doesn't know about actual assets. So we're going to actually have to create a small listener, right? So we'll do type def struct. Let's do K-asset binary asset listener. All right. Oh, I guess we don't need asset listener. I guess we could just say listener. Okay, so we actually are going to need these two. All right, we're going to need those two. And then we're also going to need a pointer to the actual asset itself, right? So k-asset binary asset, right? And then what we'll do is here, we will also create a listener, right? So we'll say k-asset binary listener. And actually, let's call this, you know what, instead of listener, let's call this context. Right, because that's actually what the VFS wants. We'll call it actually VFS context. Oops, there. Okay, so we'll call that VFS context, and then what we'll do, we'll do context equals kalloc type. K-asset binary VFS context mem tag asset, right? And then we'll do context asset equals out asset context callback equals callback, and then context listener equals listener, right? So from here, we can say context is equal to context, right? And then context size is equal to size of binary VFS context, right? Okay, so we pass along this context, right? And then we're going to get that context back from our asset data here. Okay. So, oh, this should not have been here. This actually needs to move back down here. So instead of VFS request asset sync, we're just going to do VFS request asset, right? This is return type void, right? Because we don't get anything back right away. And then we return the out asset here, right? So this kicks off a job under the hood, which when complete, we'll call this callback. So we'll do k-asset binary out asset equals, we didn't get the context yet. Let's do, let's grab this. Context equals asset data context, right? So we can say context asset, right? And then data is going to be asset data size, right? Context, content rather, is going to be this, as we had before. This is going to be asset data bytes. And then content is that, and that is actually going to do it. The last thing that we need to do here is just free up the context itself. So we'll do context. The type is going to be k-asset binary VFS context mem tag asset, just so we don't leak that memory, right? Yeah, and that's basically the way that that's going to work. All right, let me see. Let me catch up on comments here. Let's see. How is vulcantutorial.com to learn Vulkan? As someone who has a somewhat decent understanding of OpenGL, is there a better resource, or is that a good place to start? So that one's okay. It does some weird things though. So one of the things that does, and this probably won't make sense to you if you've not done Vulkan stuff before, but it has you set up a command buffer and record to it once, and then just keep reusing that to render every single frame. Which is not the way, almost never the way you're actually going to wind up doing it, as far as an actual game engine is concerned. So ordinarily, the way that it works is you kind of have all of these commands that get issued for a particular frame, right? And you have this thing called a command buffer. And so you begin recording to a command buffer, and you record all these commands to it. And then you end recording to a command buffer, and then you fire that off to a queue to be executed. And that's when the actual commands that you've queued up in that buffer get executed, right? And so the way that they do it is they kind of set you up with this toy renderer that you do that recording once, and then you just keep firing it off to the renderer over and over and over again, which is not realistic, right? Because the commands that you're going to be issuing per frame is going to change with what objects you're rendering per frame, right? And the number of objects you're rendering per frame is going to change, and there's a whole bunch of things that change. So it's an okay resource to start with. However, let me get the... I think it was VK... Was it vkguide.com, I think? No. vkguide.dev. I couldn't remember it. So this website right here, and I'll drop a link. This one's actually pretty decent resource. So this is actually a decent resource to start with. However, I am going to say this now. I've said this many times throughout this entire series. You need to actually read the Vulkan spec. Use this to understand maybe some of the basics, right? But you need to actually sit down and read the Vulkan spec. And then basically the way that you're going to have to learn this, and it's the best way to learn this is kind of the hard way, but like it's going to stick if you do it this way. So if we look up, and I don't know if you've looked at the Vulkan spec or not. Let me just pull it up. It takes forever to load on Chrome for some reason. Firefox, it's almost instant, but all you have to do is Google for Vulkan spec and just click the link that takes you to Chronos, right? So this is a gigantic document, right? Some browsers have even issues rendering it because it's so large, right? It's all one thing. Now there are versions of this that you can get that are broken up, and it's not one page, but read this top to bottom. There are some like extensions and stuff that you don't have to read about, right? But like, read this top to bottom for the most part. Start with the tutorial stuff. Get your head wrapped around the basics of that. If you know OpenGL, you'll probably know enough that it won't be that big of a jump. But at least in terms of the graphics concepts, right? But as far as the API itself goes, once you complete that tutorial, whichever one you happen to use, throw that renderer out, read the spec top to bottom, build another renderer, throw that renderer out, read the spec again, build another renderer, throw that one out, read the spec again, build another renderer. And by the time you've done that a couple of times, this stuff will start to click and make sense. Because I guarantee you, each time you do this, you're going to discover things that you did a dumb way previously. The other thing that I would suggest is while you were learning Vulkan, do not abstract any of it. Because I guarantee you that your abstraction that you think is right is going to be wrong. So avoid any kind of abstractions while you're trying to learn this API whatsoever. Don't try and build an engine around it right away. just focus on trying to learn the concepts of it, because especially when you get to things like descriptors, I guarantee you're going to do that wrong, and that's okay. You're going to do it wrong a couple of times. We've done it a couple of times wrong here, even on stream, and I've done it a bunch of times. So yeah, take your time with it. Don't try to rush through it. There is no way around it. There's only through it, right? So pace yourself, get through it however you can. But that's going to be the best way to do it. Start by putting it in a single file or CPP plus header, for example. Yes. In fact, if we take a look even in here, if we take a look at my Vulkan plugin, let me expand this a little bit. You'll see that I have a small number of files, and this number of files is actually shrinking. Most of my stuff is in Vulkan backend, right? I did separate out a couple of things, but most of this I'm probably going to wind up actually rolling into Vulkan backend. And I think before I'm done, that's probably going to be the only file. Yep. Yeah, so I would say, just keep it all in one file. And Vulkan backend is, at the moment, 5,000 lines. Now, that's 5,000 lines, including, some things like comments and that kind of crap too. But, just bear that in mind, that you're not going to want to use any abstractions whatsoever. Don't fall into the abstractions trap when you're trying to learn Vulkan. That's the single most valuable piece of advice that I had to learn the hard way. Don't try to abstract it. And even when you think you have a grasp on it, I guarantee you don't. Every time you go to abstract something, stop yourself and don't do it. Anyway, I will hop off the soapbox now, but I hope that helps. Yeah, write the code that uses it first. Yep. Then when you use it a bunch, abstract. And even then, if you've not written 2 or 3 Vulkan renderers, don't even bother abstracting it, right? You're just wasting your time. Wouldn't going through that process of trying to think through abstractions cause you to learn deeply? So I would say no, and here's why, right? Because what's going to happen is, instead of learning the API, which is your ultimate goal, you're going to wind up spending crap tons of time refactoring your abstractions instead of actually doing the thing that you're setting out to do, which is to learn the API. So I would say, completely dispense with the idea of abstracting anything whatsoever for the first few of these renderers that you write, because all you're doing at that point is wasting time. Once you've done it a couple of times and you understand how all of those things work, then you can start thinking about abstractions, maybe on your 4th or 5th attempt, right? But there's so much to this API, and there's so many concepts that you have to pick up, that abstractions are going to do nothing but get in your way while you're trying to learn it. It's kind of the same thing that I always say, don't try to learn C and OpenGL at the same time, right? Just don't do that. Learn one, then learn the next. Don't try to, create abstractions around Vulkan when you don't understand. Because the thing is, if you don't fully understand how it works, what are you abstracting? It's going to be wrong. You're going to wind up wasting your time. Trust me, I learned that the hard way. I still have to fight myself on it. And in fact, we're actually rolling back some abstractions here because I did the same thing in other parts of the engine. Fair if wide and deep enough, you have to optimize exposure to the whole space. Yes. Yeah. And that's the thing. Put that stuff off until you actually understand what you're doing. And then go ham, right? But I guarantee if you start off that way, it will be wrong. 100% guarantee it. It will definitely be wrong. Thank you for the follow, by the way. Okay. So that is all there is to loading a binary resource, right? It's actually pretty straightforward. And that's one of the reasons I chose that one to sort of tackle first, because it's actually reasonably straightforward. Now, I've probably actually done this a little bit backwards. I'm probably actually going to move the implementation of these functions into the package specific ones, and then just pass this as a parameter to the package name and call these instead. In fact, yeah, that's actually what we should do. So let's go ahead and change that really quickly, because obviously it makes no sense to repeat that code, right? So we'll do the synchronous load first. So we'll just take this one and we'll put it down here. And instead of using this package name, right, we'll do kname creates package name, right? And then up here, we'll do return asset system request binary from package sync, right? We'll pass along state. Package name is going to be state's application package name, and then we'll pass along name. What did I miss? Why is that bleating? Oh, I stored it as a K name. I should probably store it as both. I suppose I could. Instead of storing this as a K name, but then I have to create that all over the place. All right, let's do both. We'll keep a string representation of it too. And then we'll go in here to, when we extract as K name, instead of doing extract string as K name, we'll extract the string as just a string. Let's see. Why is that complaining? No member named. Did I not save that? Wait a minute, where did I... Oh, I put it in the state, but not the actual configuration object. Okay, that's why. So I guess we'll have to do both. Fine. Okay. So here we'll also do outconfig application package name equals kname creates outconfig application package name string. So we have it in both representations. And then in initialize, so we didn't actually store this off anyway, so we need to do that. Let's see, where is the... I guess we can do it here. That would have been a bug because we didn't actually start it off. So we'll do this equals config that, and then we'll do state. Thank you for the follow. Appreciate that. Welcome. Equals string duplicates. Config application package name string. Then down here we have the string representation of this as well. Yeah, that makes sense. Okay, so we've got that one. Let's take the asynchronous one, and we'll move it down here as well. And then all we have to do here is actually just take this, and then we'll just do this and pass along. Let's see, that's going to be listener and callback. Perfect. Okay. So, yeah, that's pretty much going to do it for... This is going to be the same way that we're going to set up all of our other assets, right? Now, this is one of the simpler examples, right? When it comes to loading other more complex types like images and stuff, we'll actually have to do maybe some decoding or some other things that we already have happening in our asset handlers. But this is essentially going to serve as the template that we use for all of our asset types, right? There is one thing in here that we need to do, though. In our release, we also need to check if asset content, right, and asset size, right? If we have the content and size, then we actually need to do k free. The block is going to be asset content, and then asset size, and then the memory tag is going to be asset, right? So we need to make sure that we kill that as well. Now, this is going to complain because that is a constant void pointer. So we're going to do a bit of a bad thing here, but this is also why const doesn't always necessarily matter that much, and why I kind of stopped using it. Because we can literally just cast it to a void pointer and cast away the constant. And now it'll actually just work. Right? So, all we do here is we just make sure we don't leak the memory. I don't bother zeroing it out because we are freeing the whole block of memory here. So, that is all we need to do for the releasing of a binary asset and the loading of a binary asset. Not too bad, considering, that we had to also figure out how we wanted to sort of lay this out. So all of the other types of assets are going to follow suit. And then what we're going to do is we're going to dismantle the resource system and offload all of the asset handling that the resource systems do. We're going to offload all of that to their respective systems, like the texture system, for example. And then we're not going to worry about hot reload right now. We're not going to worry about import processes right now. We're probably going to externalize the import process. Maybe do a command line tool. I haven't decided yet. Maybe we feed the entire asset manifest to a command line tool and it just goes through and imports everything. That's probably the way we're going to do it. And so we'll need to write that as well. But yeah, so what I might wind up doing is since this is the pattern that we're going to follow for all asset types, I may go ahead and do some of this offline. Right, so I might wind up actually doing some of this offline just so that we have, so that we don't take up too much stream time, hopefully, just kind of moving stuff around, right? So on the next stream, we will, kind of regroup and see how far I was able to get with this, and we'll move this effort forward a little bit more. Hopefully, I'm thinking no more than another stream, maybe two, to get all this asset work done. And then we can start dismantling the resource system. And I suspect that'll probably take a couple streams worth of work as well. And then that'll pretty much be it for 0.10. Thank you for the stretch redeem. Appreciate that. Okay, so with all of that said, this is where I'm going to end the stream for tonight. We're going to find somebody to raid. Thank you guys so much for hanging out with me. I really appreciate it. I appreciate all the new followers. And speaking of that, if you haven't already, I would greatly appreciate a follow, either on the YouTube side or the Twitch side, or if you're so inclined, both. I'm trying to grow my channels to encourage people to get into lower level tech like this so that we have a little bit more competition out there, right? So that we're not kind of stuck with the big three, as it were. So, yeah, that's the goal. Let me just see. Let me see if there is somebody doing something kind of similar to what we're doing, or along the same idea. To raid. Just bear with me here just for a minute. And if not, I see who I'm probably going to wind up raiding. Let's see. This time of night, it can kind of be difficult sometimes to find something that's, you know, C or C++ game dev, right? It's actually not quite as easy to find all the time as you might think. All right. Let's go with... Let me refresh this one more time. I think I know who I'm going to go with. Yeah, let's go with... We'll go with one of my buddies here. We're going to go with Hypnotic Games. He's a good dude. Looks like he's currently doing some modeling stuff, but we'll see what he's up to. Thank you guys so much for hanging out with me, and I will catch you guys on the next stream. And until then, have a good one, and I'll see you guys later.